Hey folks, welcome back to another video on Halide. So today we will see our first Halide code, and it will be a simple hello world kind of code in Halide. Before we jump into code, because there are very few resources on Halide, I decided to write some notes which would make it a bit easier for newcomers to Halide to get, to figure out their way around it. So on my GitHub repo, which I will link below in the description, I have started writing down notes, and this is basically what I would be covering in this video. And of course these are based on the original tutorials that are present in the Halide webpage. In addition, I also have the codes saved here. Now the thing about these codes are I have made them Linux friendly because I have added a makefile, which would make life very easy if you're building in Linux. And also, I think developing for Halide in Linux is the easiest. In Windows, it's a pain, as you've probably seen how I was struggling in Visual Studio last time. That's partly due to my inexperience with Visual Studio, and also I realized I made the mistake where I could have set all configuration instead of like specifying each configuration. That would have saved a lot of time, but anyway, it's rather easier because a lot of libraries are not present. So the libraries in Linux do not have a one-to-one correspondence with libraries in Windows. So that's a pain point for users of Windows. But this GitHub tutorial is written for primarily for Linux users because I've added a makefile, and all you need to do is just run a make all, and you'd be good to go. So the code is here, and you can definitely play with it. Um, and that's about it. So before I dive in, for this particular example, apart from Halide, um, apart from Halide.h, you would need certain other libraries. So first one is Halide images. Halide images.io, which is basically a header that contains tools for reading images, loading images, and saving images. So this is not a big deal because this is already in your Halide repo that you've downloaded, so you'll already find it. So this is not a big deal. The other libraries that you need are deal with images. And let's open the makefile. So these libraries are, so there is libpng16 and then the JPEG library. Okay, so PNG16 you can find on Windows, but JPEG, there is no, I couldn't find a JPEG version of this library, the libjpeg. So I had to use JPEG Turbo. And so the way you would install these libraries is you can build them from scratch, or you can figure out a way to download them. I use the VC package manager. So let me open this. So this is the VC package manager. This is like apt install, or it's like pip, which all you need to do is specify the package that you want, and it will install it for you. So um, for for libpng, all you need to do is all you need to do is type in this command, VC package install libpng, and then the architecture. Of course, you need to have VC package manager installed, but this makes life much easier. I'd rather just use this in Windows. For JPEGs, I urge you to use Turbo JPEG. So let's see. Yeah, so it's called this thing. Yeah, all you need to call is VC package, install libjpeg-turbo and x86-windows. So that will install the two libraries that you will need for running the code in Windows. So I even though I'm discussing about things in Windows, the point is not the Windows or Linux or these operating system aspect of things. The point is to learn Halide. So I would try to I'm trying to reduce the complexity of this whole which operating system, which environment are you using. Just trying to reduce that as much as I can. And we'll spend more time in discussing the code and less time discussing, all these operating system and IDE aspects of things. All right, so with that said, let me jump into my Visual Studio session. And here I have the whole code pasted out. So let's first go over it. Okay, so because I'm using Visual Studio, let me show you my project setup. And so first of all, let me go over the include directories. The package manager makes it easier for me to, so what the package manager does, and this is the reason why I urge you to use package manager, is whenever you install a package through package manager, it install all the libraries, all the headers, and everything in one directory. So you can see I have the same include path or the parent path for each of these. So this is the blanket path that includes all the includes that I should use. This one is for libpng, and this one is for Halide tools. This is the IO thing that I mentioned before. Then, sorry, that was all the include path. So I keep messing up library and include. So this is the library path where all I need to do is specify /lib, and that specifies because all the libraries are stored here. That's one thing. Then I go into C++. I've set the language to be C++17. So in language, it's C++17. And then I also specified a preprocessor directive this that uh, I just had to specify this because otherwise it was erroring out, giving me a warning because of file IO, some deprecation happening there. The other thing, but then this is not so important. The other thing is specifying the libraries. So I go here, and these are the libraries that you would need: Halide, JPEG, and libpng16. All right, that is the setup. Now, a very important thing is, even though I spent a lot of time in the previous video talking about the release configuration, henceforth I will only use I talked a lot about debug configuration. Henceforth, I will only talk about the release configuration because that's the binaries that people have easy access to, and we can debug using prints. So yeah, so from now on, it's only the release configuration. All right, so let's jump into the code. The code is a very simple one. What it is trying to do, that it is trying to brighten an image. So given an image, let's try to brighten it up. And how do we brighten it? We would brighten it by a factor that we pass in. And brightening is a very simple operation. You figure out what's the value of each pixel, and then you add a factor to it. So you can multiply by a factor, but then the way we are implementing is we would add a factor to it. So let's say if I brighten things by plus 10 value, so all the pixels get added up by plus 10. So that's how I would implement brighten. So the first thing is, here I have the first function has a manual implementation. Basically, I will loop over each pixel and then brighten it up. And then the second implementation is using Halide. So that's pretty much it. And the main function calls both those functions. Right. First, we begin by including stuff. Everything that Halide needs resides in halide.h, so you don't need anything else. For IO stuff, you will need Halide image underscore IO, so that's just for loading and saving the images. And then this is a pretty straightforward bit. Let me walk over the brightening operation. So this bit of code is just a utility code for loading an image and getting handle on the data. So first, Halide images are stored in buffer objects. So I create a buffer that will load my image. So I have an image from Futurama, and then basically I store in the height, width, and the channel of the image by calling the specific functions. Now that's good. Now I have an input image, and the way that I'm doing the brightening operation is that I create a new image, which is the brighten one. So I'm not doing this operation in place. So I need to create a new image by the creation constructor. So I create another buffer object, and its dimensions are specified by the same dimensions of the input object. Good. So now that we have the buffer object, now we need to get access to its data. And so we create pointers, And these are unsigned int8 pointers because images lie between 0 and 255 pixels, so that's an int8 unsigned. So I create two pointers that point to, so this method is used, get and then data. That basically yields the pointer of the very first pixel, the pixel at location 0, 0. So we get the pixel, rather the address of the pixel at the pointer to the pixel um, at the starting point, and this is at the end point. Now, always remember, images are not laid down in a two-dimensional format. Images are laid down in a single row. So your let's say you had a one channel image, it'll be laid down in a single row. Since you have a three channel image, it would be laid down in two possible formats. We will not get into the formats, but it could be interleaved. By that I mean, first for the first pixel, you could have the red pixel value, the G pixel value, B pixel value, and then for the second pixel, RGB, and then RGB and RGB. So this is the interleaved format. Or it could have a planar format where all the R's come first and all the B's come first, or G's come first and B's come first. So you could have like these memory layouts. I'm not sure like how to go between them, but then we'll figure this out as the series goes. So, but this for the brightening operation, that's not very relevant because um, you are adding a factor to each pixel. So you're not channel is not a consideration here. This you because you are adding the same factor to all the pixels of the image, it doesn't matter how you do it. So I can treat both the memory layouts as the same. It doesn't matter. So I loop over the height and I loop over the width. So I'm looping over all the spatial dimensions. And then basically what I do is at this address. So okay, so I am doing everything is output buffer plus because output buffer is the initial position, and then how far further down the line are we? So that's why I have a plus. So we start from here and add values to it. So at this location, store this value. And the reason why we are doing 3 times is for to account for RGB. So basically, this is the logic. This tells you the row number and then the column number, or vice versa. So, and the 3 is here because I am taking the interleaved convention. So what's happening is, first of all, at this location, I take the value of what the input image has. I add a factor to it, and then I clamp the value between 0 and 255. So what std clamp does, it puts a lower bound and an upper bound. So this is a C++17 function. Um, yeah, so here's the value and then the lower bound and upper bound. And then I do this for R and then G and B. That's why a +1 and a +2. So you can figure out the math why I did J times W, because I'm scanning over each rows, because I have to skip the number of the column numbers. Sorry, I keep saying that, the column numbers when I have to go to the next pixel, um, because next pixel in the column. So I have to move over all the next pixel in the row. I have to move over all the column values. So this is just basic math. If you just spend like maybe think about it 5 minutes, you will be able to figure it out. Now, the commented part is for, let's say the layout was planar. This is how you would deal with the planar layout. And again, for this code, it doesn't matter because we are adding a factor to each, the same factor to each pixel, so it really doesn't matter. And then finally, we save our output buffer to manual.jpg. That's pretty much it. So it's a very simple operation, and we're looping over both the spatial dimensions. I could have made it easier by looping over, I could add a third loop by looping over the channel dimension, and then I would have a single line command, but it doesn't matter. Okay, so that's how we implement brightening manually. Let's see how do we do it in Halide. First things first, we again read the image, straightforward. Then I create a func object, a var object, and an expression. So let's see. Vars are like variables in Halide. So they are used to store the dimensions and so on. expressions determine the computation pattern, like what I am doing with the vars. Am I adding them, subtracting them, or they represent the computation graph. That's what expressions are. And a function or func consists of expression and var. So you should think of func as being made up of vars and expressions. Now, func is the object. It's the object, or it's rather the only object in Halide that can be scheduled. So you define your computation in a func. So it's a single stage in your pipeline. Let's say first I was brightening and then I was dimming it. Let's say I made two separate stages. So I would have two funcs for brightening and then dimming. Now, each of these func can have some computation within it, and computation is made of vars and expressions. But each stage in this pipeline, each func object is the only object in Halide that you can schedule. So by schedule, I mean this func can be parallelized, can be unrolled, tiled, and all sorts of fancy things can be done to it to increase its performance. So this is the object in Halide that you use to schedule. In this video, we won't deal into scheduling. I'll leave that for a later video, or rather the next video. But here, I just wanted to mention that. So we first get the value at the pixel. So, okay, before that. So first of all, I define three variables. And I need to define three variables because I have three dimensions. So in the expression, I obtain input x, y, z. So value gets the value of each pixel corresponding to the original image. Now, this is a very different way of writing things. In C++, you would have for loops where you assign each thing, but here you do a direct 1:1 mapping. So once we have the value, we cast it to int, we add a factor to it, and then I cut it off at 255, and then I cast it back to uint8. I could have done it like in different ways. So this is just one particular way I've chosen. Rather, I got this code from the tutorial, so that's one way that they chose. And then finally, we assign our func, we assign value to our func. So my func is basically this whole expression. So this thing could have been written down in one line, but this has just been decomposed. So this is my func, which is made of all the expressions and variables in value, because you can see, so here's are the variables, vars rather, and the expressions. Okay, so, and the way, and again, you see the same notation again. This refers to the first index, x and y index, and this refers to the color dimensions. I do a 1:1 mapping in which I don't have to write loops. Finally, so at this point, so this is my algorithm. That's the Halide algorithm for brightening. That's it, done. No for loops, nothing required. Now I need to realize it. Realizing it means compiling it and set it up for scheduling. So basically what I do is I create another buffer object to store the output image, and then I call the realize function. Now this basically dispatches it however you want to dispatch it. If you want to parallelize it, unroll, and all that jazz. And then I need to specify how many dimensions am I looping over. So here I have width, height, and channels and their values, because that tells me how many dimensions this Halide pipeline would work. And when I call realize, this is when it JIT compiles my func. So realize is used for scheduling, rest is the algorithm. That's pretty much it. And then finally we save our image into a new uh, image, or save the buffer. So that's the Halide code for brightening. Now, one thing to realize is at this point, the performance of this code would be the same as the Bright manual, because we haven't used any fancy scheduling. We haven't done anything fancy with it. So you would see that. So when I call realize, what it does is it has 3 for loops for channels, for height, and for width. So its performance wouldn't be any good. In next video, we'll see how to add scheduling to it. So uh, that would increase the performance of this and would include some fancy things. And finally, I call both the functions with a factor, and then, well, factor is a wrong term that I used, but, and then I return it. All right, so that's how Halide works. Let me build it. So I build it by Control B, and you can see true build started, and my build was successful. Build succeeded. So now let me run it. Um, and success. So it ran successfully. So let's go back and let me open my Windows to see. Let me bring it. So you can see this was my, not here, I'm in release mode. Oh, uh, I keep forgetting where things are. Right, yeah, here in Brighton. So this was my original image, and then this is the brighter one. So if you see, this is the manual brighter one. Now this is the Halide brighter one. It's the same thing because it's the same operation, but you can see the brightening operation. So that's it for this video. Um, I hope, because it's a learning experience for me as well, because I don't know Halide, not a lot of resources available, but then bit by bit we'll try to uncover different aspects of it, and it's not too hard. All right, so next time we'll see scheduling, and we'll time these operations and try to see what the output looks like. That might be more useful, seeing um, what the halide output when you call realize looks like. Okay, all right. I think that's it for this video, and I will see you guys next time.